Right. So always start such questions with timeline. This is a simple question. You may feel that you can directly use the formula, but when we handle more complicated questions, you will appreciate why timeline is required, right? But then it may be very difficult to use. So with the simple problems itself, start using the timeline. That is my advice and a suggestion and also a request, because I really want you to do well. Right, so an investor wants to have 1 million when she retires. So start with a timeline. She wants to have 1 million, so that 1 million will come here, which is the future value. She can earn 10% annual return, so that is 10%. You put the 10% here, right? Compounded annually on her investments. The lump sum amount she would need to invest today to reach her goal is, so what is this present value? What is the present value is the question, right? So future value is 1 million, 10%, and this is 20 years. So when starting with 0 here, 1, 2, and likewise, this is 20. So we know N is 20. We know the future value is V. We know R is 10%, meaning 0.1. What is present value? Right? We can again do the same using the Excel application. Right? The same thing. Future value is given as 2 million. Right? 2 million is how many zeros? All those of you are into accounting. Am I right in saying this? No, one less. 1,000, 2 million. Is this correct? Right, that is future value, and R is given as 10%, meaning 0.1. N is given as 20. Right? Or is it 1 million? Sorry. Right. So present value is what we are after. Present value is something went wrong. It is 20, which is H4. Oh, that's 0. Right? I gave O instead of 0. Thanks, Kadir. I'm glad. I'm very happy that you are all with me. So if I'm making mistakes, it's good that you are pointing out. That means you're all attentive. All right. So it's 148, 643. Right? Did you all get this? Is this part clear? How did we calculate the present value? We used the Excel here. We could use the same formula that we have discussed previously. We could say present value equal to future value, that is 1 million, into 1 plus R to the power minus N. Right? Or you could say future value divided by 1 plus R to the power N. Please note that. This is not a mistake. What did I put there? Minus n. Future value into 1 plus r to the power minus n. Because if you have future value, if you have a formula like this, future value, you can also say divided by 1 plus r to the power n. Right? This is in the denominator. If this part, this whole thing here, if I want to bring it to the numerator here next to SV, then the power will become minus n. Just like in algebra, those of you who are what did we get here? 148,643. Yeah, it is 1 million. What is it, Deepak? You're saying the value is 100,000 and not 1 million? I did give 1 million. 100,000 is 5 zeros. 1 million is 6 zeros. And we did get correct 148,644. We got 643, but that's fine. Right? Deepak, check your value. So I was saying here, future value divided by 1 plus r to the power n is the formula for present value. This 1 plus r to the power n, which is in the denominator, if you move it to the numerator, I was saying, those of you who are aware, if you have an equal to sign here, you know, in the algebra we have, let's say, plus 2 on the right hand side of the equal to sign. If you want to bring this plus to the left hand side, it becomes minus 2. Right? The plus becomes minus. And likewise, if you're dividing one side, it becomes multiplication on the other side and the other way, and vice versa. So likewise, if you have a power here in the denominator, you bring that part to the numerator, it becomes minus n. The power becomes minus n. That is what I'm trying to tell you. So you can write the formula this way as well. Present value equal to future value into 1 plus r to the power minus n. This is also valid formula. Or you can write present value equal to future value into, divided by 1 plus r to the power n. This is also a valid formula. Right? You can use it, you can apply the formula and get the value. Or you can use your financial calculator or your Excel. So this is how it is being solved. 6 zeros is 1 million. N is 20. Time is R equal to 10%. Present value equal to future value into 1 by 1 plus R to the power n. Right? Here it is shown as whole n, but generally when we write the formula, this n should be inside here. Right? Please don't make that mistake. When you look at this formula, this n is whole, but try and bring the n here. It is to the denominator. Generally try and put it that way, because most of the books follow that notation. Right? So this is how it is, 1 by 1.1 to the power 20. Times present value times 1 million will give us 1 by 1 plus r to the power 20 is 0.14864 times 1 million is 148,644. Is this clear, everyone? Is the solution clear? Please go through the solution and ask me if you have any issues. So we'll go to the next one. Now when we're talking about interest rates, there are 3 ways to look at it. Generally, what are the returns required? Right? If I am investing 100 rupees today or 10 rupees today, how much return I am looking to earn in X number of years? I want to earn some return on top of this 100, something extra, plus 100 or 10 plus something extra. What is that extra? That extra is the return that I want to earn on my investment, which is 10 rupees. right? So when you look at the interest rate, one way of looking at them is how much return an investor requires, right? The same thing you can also call it as rate of interest, right? And then we also use a term called discount rate, which is the generic term that measures the rate of return reflecting the time value of money. Time value of money is reflected in compounding rate and discounting rate. So we are not specifying is it future, is it present. We are only saying discounting rate. So we know that a future value is given and we are calculating the present value. When we say compounding rate, we know that a present value is given, we are calculating a future value, right? So that is the rate that we are looking at in terms of time value of money. Now next we call it as opportunity cost. Generally any opportunity cost is what is the next best option, right? How much it is to forego what we have now, right? If I have to forego this, how much, what is the cost associated? So even that we call it, that can be taken as the interest rate, right? So opportunity cost of capital we say, right? What is the cost of it? Again, I'm not going into depth. Some of you, if it is not completely clear on how this opportunity cost is linking to interest rate, don't worry, right? Because when we come to weighted average cost of capital, we will try and understand first of all, what is cost of capital, what is the cost that we are talking about. Then we talk about what are the weights. Then we talk about what is the opportunity cost of capital, right? So don't worry. Some of it, I don't want to confuse you too many terms. But here you have some basic understanding about not the opportunity cost of capital, but generally what is opportunity cost, right? So just please go through this as I'm reading. Difference between a particular action and the value of the best alternative, right? If you forego something, I am getting a rent of 20,000. Now I want to vacate those people and do something else. I want to set up my own company in that premises. So I am foregoing this 20,000 rent. So if I am setting up my own company, will I get enough return that will also compensate me for the 20,000 that I lost? Right? That is the opportunity cost. The 20,000 that I am losing is the opportunity cost. Right? Explicit recognition of the reality that taking an action eliminates other revenues and options. Taking one action, I am trying to start a company in these premises. That is the action that I am taking, and what is the consequence of that? That I am foregoing the 20,000 that I was getting until this point. Right? So what does it indicate? It indicates the relative importance of a decision. So generally, when do we do that? We do that when this startup that I am going to start in this premises is going to be, or is going to give me more returns when compared to that 20,000, right? So it only shows that this decision that I have taken has got more importance when compared to the 20,000 that I was getting, right? It is trying to understand what opportunity cost is. If the opportunity cost is small, then it means that the cost of incorrect choice is small. If the opportunity cost is large, then the cost is large, right? If I am foregoing just 2,000 rupees of rent, then that's okay, it's not much. If I am foregoing 2 lakhs, then I better, whatever I am doing here in place of the 2 lakhs, better give me good returns, right? Because the cost is high. The cost of foregoing is 2 lakhs, it's high, it's not 2,000. So whatever I am starting here, it better give me good returns that will compensate for that loss, right? Because the cost, the opportunity cost is 2 lakhs and it is high, right? But generally, whenever we are starting, this is not completely obvious. It is hard to calculate. It is not always obvious or easy to calculate. So we generally cannot pinpoint and say this is how much it is. So we understand what opportunity cost is. Sometimes we are able to calculate, but it's not always easy, right? Next, just trying to understand the discount rate. By the way, before we proceed to this, any questions? Because you all become a little quiet. Param, Santosh, Deepak, Amit, Kaderi, Ashwani, Anil, Nagaraj. Nagaraj, you become quiet. Amit, Gunasekaran, Vikas, Alok, Chetan, Srinivasan, Raja, Rajmohan. Is it clear? Any questions until this point? Gangadhar, no issues. Alright. Good. So let's proceed. See, the reason I keep asking you every now and then is you get to see my face. I don't get to see you all. So unless you type in something here, I will not know. Right? So it is good that we are interacting, and I really appreciate all your effort in trying to type in something for me. But if the class is interactive, then I understand that you're all following. Otherwise, I'm just looking at my face and explaining to myself. Right? Alright. In calculating the present value, choice of discount rate is fairly critical. Right? We are saying discount at 10%, discount at 8%, whatever that is. So it is very important. So why is it important? This particular graph shows us. Right? Let's say present value of 100. Right? We are having present value on one side, we have the time period on one side, and these little lines here, these curves here mean different discount rates. Discount rate 0 is that line up top up there. The second one is discount rate 5%, discount rate 10%, as you can see here. Can you all see here? So these are the different discount rates that we have used. So present value 100. Right? If the discount rate is 0, if there is no discount rate, future value is 100, and if you are trying to calculate the present value of it, there is no discount rate, meaning it will stay 100. Right? It is Are you all there? Alright, sorry, briefly the internet went away, but we'll just try to wind up this session. So what we are saying is $100 is what we have here, and the interest rate or the discount rate is if it is 0. So when you calculate the present value, it will not change. Ashwini, that's all right. I'm using my mobile hotspot to get the internet connection. So if you can please bear with me without a video, that should, as long as you can hear me clearly and see the screen, that should be okay for now. Right? Once the internet comes back, then it should be, the video will be turned on. All right. So if the interest rate is 0, it will be the same. Now, if the interest or the discounting rate is 5%, what will happen to the present value? The present value will be slightly lower, right? If you go to third year, if you go to fourth year, fifth year, sixth year, seventh year, the present value is decreasing. And likewise, if you can see, decreasing meaning here it is almost, if you go to the 11th year, it is almost 61, 62, right? So likewise, if we increase the discount rate to 10%, what is happening? The present value is further decreasing. So what is that we understand? As the time period increases, also the present value decreases. As the discount rate increases, also the present value decreases. Is that clear? Right? So this is what it is. As the time period increases, the present value decreases. As the discount rate increases, also the present value decreases. Right? That is what we are trying to understand. Now, some of you asked me about inflation. Gunasekaran asked, is discount like depreciation? Is discount like depreciation? Gunasekaran, discount is removing the interest part, right? Depreciation is decreasing in the value. So if you have some commodity, if you have something like let's say a car or something, the value of that will decrease over time, right? But here the value of money, in a way you can say yes, but here you're not depreciating the value. The 100 rupees not depreciating. The 100 rupees is still the same. What is decreasing is the overall value, because you're removing the interest part from it, right? So the 100 rupees, if you talk about, the 100 rupees is not decreasing. Whereas when you say depreciation, the car, the value of the car, whatever that was, that is depreciating, right? But here you're just removing the interest part. Right? So for some reason I'm not able to see all of your charts. I'm just seeing one by one. So Ashwani is saying, where are you, Ashwani? Whether this curve shows PV is lower than FV, it does show. What we are saying is present value will be decreased in the sense is, we are not talking about the worth of it. What we are talking about is the value in terms of, the figure. If you are saying 100 now, the same 100 will become 121 in future, right? So if you're talking about 121 or 100, then what that 100 will be now? Will it be 80 or will it be 60 or will it be 40? What will it be now? Is that clear, Ashwini? Right? Senthil asked me, is there any possible that interest part will be static as the year goes. So generally, in reality, we can fix the interest rate for a certain period of time. If you go and borrow money, if you go to a bank, sometimes they allow you to fix the interest rate for 2 years, 3 years, right? So you can fix it, but generally, if it's a longer term, then you cannot fix it. Then it will be a variable interest rate, whatever is in the market at that particular time. Is that clear? Now, in a certain world, interest rate is the risk-free rate. Risk-free rate meaning a guaranteed rate, no risk rate. In a certain world meaning in ideal world. In ideal world, there should not be any risk involved. If I am giving you 100 rupees, if the interest rate is 10 rupees, it should be 10 rupees, right? So I am telling you 10 rupees and you borrow money. Like we go to the bank, we say I am borrowing money, now the rate is 5%, let's say, and I am borrowing money for 20 years for my home, right? So for 20 years, if I know that the interest rate is going to be 5%, then I know I can plan my things well. But in reality, will that happen? In reality, there are so many things that change, right? So the interest rate also changes. So when you're saying in a certain world, meaning in an ideal world, whatever was told to you in the beginning, if the same thing holds good for the entire period of the loan, then it is good. In ideal world, that is good. But that won't happen in a real world. In a real world situation, there is no guarantee. In real world situation, the rate fluctuates, right? We're just trying to understand the inflation impact. So, in a certain world, interest rate is risk-free, meaning guaranteed return. So, where will it be guaranteed return? There will be some places where it is guaranteed return, right? Generally, if we have government bonds, right, treasury bills, which are short-term bills, short-term bonds, then it, like I said, 2 to 3 years, you can fix it for a certain interest rate, right? 2 to 3 years or if it is short-term, that's okay. But if it is longer term, even that won't work, right? So some places you can have risk-free. But in real world, what happens? There are two things that impact the interest rate. What are those two things we discussed? We said when the time is appropriate, we'll talk about inflation. Inflation is one thing that affects it. Lenders charge an inflation premium to account for expected increase in prices. Right? If there is inflation, if, let's say, it may not be the correct example, but we'll just take up some example. Today, the value of a certain goods is 100 rupees and tomorrow the same thing became 105. So there is an increase, inflation of 5%, right? So if there is inflation of that particular good and I want to buy, see I kept 100 rupees aside to buy, let's say, what will come for 100 rupees these days? Let's say I want to buy a mobile phone for 100 rupees. I'm just giving you some crude example. But you came to me and asked me if you could borrow that 100 rupees, right? And you said I'll pay you 5% interest rate. That is what is there in the market, right? You said fine. You gave 100. I gave 100 rupees to you. But this 100 rupees, with this 100 rupees, I wanted to buy a mobile phone. But after 1 year, when you return 105 rupees, this mobile phone has become 107 rupees. So who will pay the difference of 2 rupees? Had I bought it today, I would have got it for the money that I had. Now, in future, next year you return that 100 rupees plus 5%, which is 5 rupees interest, you gave me 105. But now the mobile phone is 7. What do I do? 107 now it is. So in reality, this inflation plays an important role. Because there is inflation, there will be change in the interest that is being charged. So when I give you, I may say 5% is what you have to pay me, right? But after 2 or 3 months or 6 months, when the inflation rate is announced, then I understand that I won't get the mobile phone for 100 rupees. So I'll go back to you and say, now it is not 5%. So when you return to me next year, from this point onwards to the next year, the interest will be calculated as per 7% or 8%, whatever it is, right? That is what in reality, that is what happens in reality. So what is that is impacting the interest rate? Inflation is impacting the interest rate. right? It will only impact it. It is not added to it, right? It generally impacts it. So based on that, lenders charge an inflation premium to account for expected increase in prices. So what will normally happen? I gave you 100 rupees. When you took, I said 5% interest, right? After a few months, we're talking about, let's say interest is compounded monthly. After a few months, I came to know that the inflation is 7%. So I want to adjust my 5% interest rate. I want to adjust it. I'll say, give me 3% more. So inflation is 7%. And I want a little more interest on the money that I lend to you. So give me 8%. No, it's no longer 5%, give me 8%. So that is how the banks adjust it. True. Vikas says ideally interest should be able to beat inflation in any investment. That is true. So I want to beat it. Now if I want to use the same 100 rupees to buy a mobile phone today, I would have got it for 100. Now if you return 105 next year and if the mobile phone is 107, then I won't be able to beat the inflation which is 7%. Right? Inflation is 7%. How did I say 100 rupees is the mobile phone today? Tomorrow it is 107, meaning the inflation is 7%. When I say tomorrow, sometime in future, let's say after 1 year. So when you return after 1 year 105, I'm not able to beat inflation. Now I can't buy the mobile phone for 100 rupees or not even for 105. Right? There will be a difference. So generally people always make sure that they beat the inflation. Right? So that is why the inflation impacts the interest rate. So what normally lenders do, people who are giving you money, what do? They normally adjust it according to inflation. They try and adjust the inflation. So they normally charge the inflation premium. I'm giving you 100 rupees, I say 5% is the interest. Now I'm increasing it to adjust for the inflation. So I add the premium, inflation premium. The inflation is 7%, so I'll say, okay, I'm increasing by 2% or I'm increasing by 3%. So whatever 5% that you give me, on top of it, you also have to give me an inflation premium, which is whatever I mentioned, 3%, 5%, 2%, whatever it is. Right? So that is one thing that normally happens in the real world. And what is the other thing that normally happens or normally impacts the interest? That is the risk. Risk also impacts the interest. So compared to governments, there is risk inherent in lending to private companies. There are a few questions here. So before we go to that, we'll just see the questions. Right. A few questions here. Selvam says, is it same diminishing rate and discounting rate are same? Somebody who is in accounting can answer that question. Is it same diminishing rate and discount rate? Diminishing rate, I think, is used in depreciation more. So as this year you deduct 20%. Next year you deduct 15%. The year after you deduct 10%, that is the diminishing rate. Selvam, if I'm right, I do not have accounting background, but I'm just trying to answer your question. If I'm wrong, somebody please correct me. So when you say diminishing rate, especially used for depreciation, I bought a car for 1 lakh. Next year its value is depreciated by 20%. The year after, if I'm depreciating its value by 15%, and the year after I'm depreciating by 10%, and likewise, we call it as a diminishing rate. The rate is decreasing. When you say discount rate, the rate is staying at 20% or 10%. Every year you're discounting or you're deducting the same amount. That is a discount rate. But we call it discount rate because you're removing it. You're removing the interest part, that's why you're calling it discount rate. But if you're adding the interest part to calculate the future value, then you call the same thing as compound rate. So don't go by the term discount in the discount rate. You use the discount rate term because you're removing the interest. Is that clear, Selvam? Selvam, is that clear? Does that make sense? Nagraj is saying, you mentioned weighted average value. I assume it is a way to evaluate a project considering the time value of money and other intangible aspects. Nagraj, we will come to it when we do the weighted average, because I have to give you a little bit of background on it, which will be deviating, right? So, but we will come back to it. Vikas is ideally interest should be able to beat inflation in any investment. Yes. Could you please tell us the finance factor which contributed to the hike in PV as time goes because of inflation? Sorry, Senthil says, could you please tell us the finance factor which contributed to hike the PV as time goes because of inflation? PV is not, okay, generally if you have any discount rate of let's say 10%, when you remove that interest part, right, you will have certain PV value. But if the 10%, but in real world we are saying we try and beat it, right? We generally try and adjust the inflation into the interest rate in real world. But when we come to solving these problems, we do not consider that so much. So if you are saying this year the interest rate is this much, we are only taking that much. If you are saying for the next 10 years the interest rate is 10%, we will take 10% for the next years in solving our problems, right? But generally speaking, whenever the inflation is adjusted into the interest rate, the government, the RBI will declare that, right? So we are not doing it ourselves. So we do not include that in our calculation. What we are trying to understand and learn in this course, Managerial Corporate Finance, is how do we calculate? Now, if I am taking a loan from a bank, how do I calculate what is the right payment, right? What is the right interest rate? If I am going to another bank, if they are giving me another interest rate, what is it? I am trying to understand those calculations so I can calculate and make a good decision, right? Adjusting the inflation into the interest rate, all that we are not doing in terms of calculation in this course, right? So whatever we do is we get an adjusted value and we use that value for our calculations, right? Is it clear, Senthil, what we do here and what is expected of this course? All right. Can we move on? Now, risk is one other thing. Somebody asked me, Senthil is asking me, any norms or yardsticks for depreciation in terms of commodity. We are not talking about any depreciation because it becomes more accounting, Senthil. In finance, we generally use it where appropriate. So when we come to a topic called capital budgeting, briefly we use depreciation, right? That is also a straight line depreciation method. Again, those of you who don't understand what straight line is, don't worry. When we come to it, we learn. But we only use one depreciation method, which is a straight line depreciation method. That too, when we are doing capital budgeting, we do not go and dwell more into depreciation and the more of accounting concepts in finance. Some of it which are standard, we just borrow it from accounting and use it here, right? And anything other than this slide, we will be discussing as it comes. What I suggest to you is, if you have any questions, and wherever I am saying, this topic will come later, we will discuss them. Whenever I am saying that, kindly note it down somewhere. When that topic comes, if I am not answering the question, please do ask me then, right? So let us not deviate. And Amit is asking me about debentures. Again, Amit, when we come to valuation of bonds and debentures, similar concept. That is when we'll discuss about debentures. Okay. So let us not deviate too much. So risk compared to governments, there is risk inherent in lending to private companies, driven primarily by business dynamics such as industry, climate, competition, economy, etc. This is typically referred to as default risk. So what is the risk here? So if you are borrowing money or if you are lending money, let's say you are a bank and you are lending money, you lend it to government, you know that you would get back sometime. But if you lend it to private companies, there is always a default risk. They may not pay you back. right? They may not pay you back. That is always, there is always that risk associated. So then we take that risk into account. Again, this will come into picture when we again try and where does this come? When we are calculating the, yeah, when we talk about risk and return, then we will discuss about it, right? But for now, in this slide, in this part of the course, what you need to understand is what are the different things that impact interest rates. The two things that we discussed so far is risk and inflation. These are the two things that impact the interest rate, right? Is that part clear? Again, anything that I am not going into detail, please make a note. I am also making a note of your chat. So, we will all be on the same page when the time comes. And when we do the revision during midterm, let us see if you have answered all of those questions. Okay? Alright. So, we will move on to the next slide. We have few more minutes. Then we talk about frequency of compounding. Now remember in the conversation, during the conversation I said at the end of the year this much you pay. And I am also saying when you take a loan, usually that is monthly compounding, monthly installments you pay, right? So what is this monthly then? Why is it sometimes yearly payment? Why is it sometimes monthly payment? It depends on how the lender, how somebody who is giving you the money is calculating his interest, right? If I give you 100 rupees and I say I calculate interest only once a year and that is 10% per annum, then at the end of the year 100 rupees plus that 10% you have to add, right? But if I am saying I'll give you 100 rupees but I'll calculate interest every month, then what is the compounding? Compounding is happening how many times a year? 12 times a year, because I'm saying I'm going to calculate the interest 12 times a year, every month. There are 12 months in a year, right? So likewise, there is something called compounding frequency. If I'm saying 1 year, if I'm saying 1 year, then yearly one time I calculate. If I'm saying interest is calculated half yearly, annually is one time a year, let's say annual year. If I'm saying half yearly, there are 2 halves in a year, so interest will be calculated 2 times a year. If I'm saying the interest is calculated quarterly, then we know there are 4 periods in a year. 4 times you calculate the year, interest. So what is this 1, 2, 4? It is nothing but compounding frequency. This is something called compounding frequency. If it is calculated monthly, then there will be 12 times we need to calculate interest. So this is compounding frequency is equal to 12. Right? So this is the compounding frequency. So every time in a question, when the interest rate is given, usually there is a 10% per annum. But interest is calculated monthly. So how do you do that? Generally, if you put a timeline, that is time 0. Senthil is saying slide is not moving. I am not moving any slide. I am writing on the slide. Can you see, Senthil? Can you all see what I am writing on the slide? Can you see the annotations, please? Ashwini is not able to see. Nobody is able to see. Oops. Why are you not able to see? Can you see the slide at least? You can't see the slide? Alright. Let's see. Anyway, it's time. Okay. So what actually happened is, I'll just pause the recording. The frequency is more than 1. Then we adjust the value of n, which is the number of periods, and we also adjust the interest rate r. How we adjust that we will see in tomorrow's class, right? I'm sorry if the slide is not moving, but for now, anyway, because it's time, we will stop here. But those of you who have the textbooks and who can go through, please go through frequency of compounding. What are the things that we adjust when the compounding frequency is more than once a year, right? If it's more than once you're calculating, two things we adjust: the value of n, which is the number of compounding periods. Normally, if I'm saying 1 year, then I have only 0 and 1, right? 0 is now, at the end of 1 year is 1, right? But if I'm saying monthly compounding, there will be 12 in between. So the n value will not be 1 anymore, it will be 12, right? So like that, n value will be adjusted. Also the value of r will be adjusted. Those two things we will discuss in next class, which is tomorrow, right? Alright, no issues. I think the internet has come back. So what I'm trying to show here is compounding frequency 0 and 1, but if there are if there's monthly compounding, 1 month, 2nd month, 3rd month, etc., 12 months, so n will be 12 now. And likewise, r will be 10% divided by 12. So two things we adjust, right? But anyway, this frequency of compounding from this slide onwards, from the 16th slide onwards, we will continue in tomorrow's class. Alright? Those of you who can revise, please just go through this part here and we will discuss about it tomorrow. And we will wind up today. It's already 11:05. We'll wind up now. Any questions so far? Any questions? Param, Senthil, Amit, Ashwini, Nagaraj, Giri, Anil, Amit, Gunasekaran, Selvam, and Amrapal says no. Alright, so we'll stop here. Please go through all the things that we discussed so far. And like I said, time value of money, we'll take it slowly and we will discuss a lot of questions. Right? We will also try and solve them in the class. You please solve it with me. Keep a pen and a paper ready. Also your Excel or financial calculators. And we'll try and solve as many as we can before we go into other topics. So with that, I'll end this session. And tomorrow again we have at 9 o'clock. We'll continue with frequency of compounding. Alright? See you tomorrow then. Right. If you have any questions, Senthil is saying he sent me an email. If you guys have any questions, you please send an email. If it is something that I can answer, I'll definitely answer. So with this, we will stop the recording.